Alright guys, we have 9.7 differences of two squares. The learning target is I can recognize and factor completely quadratic expressions using the difference of two squares pattern. Alright, so this is actually pretty sweet. It is just a shortcut to help you factor something that has two squares, okay, a squared and b squared, and it has subtraction. Alright, so remember that the expression is called a difference of two squares. Notice we have this subtraction in the middle. Alright, so if we want to notice we have that subtraction, we know we can apply this kind of shortcut. Alright, I need the subtraction and two squares. Alright, so you maybe remember seeing expressions like this one when we did multiplying expressions. Alright, we had a plus b times a minus b. Okay, remember I said if you had the exact same thing, a, b and b, one had a plus, one had a minus, that instead of doing FOIL, okay, we can just do the first and the last. Okay, so I did a times a and I got a squared. I did b times negative b and I got negative b squared. So that was my answer. Alright, that's basically what we're doing here, except we're going backwards, so it's a little shortcut if we notice that we have two perfect squares. Okay, so remember, an algebraic term is a perfect square when the numerical coefficient, the number in front of the variable, is a perfect square, and the exponents of each number of variables are even and are perfect squares. Alright, so those would be, okay, perfect squares are numbers like 1 squared is 1 times 1. 4 is 2 times 2, okay, or 2 squared. What else? 9 is 3 times 3, or 3 squared. What else? 16 is 4 times 4, or 4 squared. What else? 25 is 5 times 5, or 5 squared. Okay, and so on. Alright, so the leading coefficient, the number needs to be a perfect square. Alright, and then the variable needs to have an even number. Alright, if it's an even number and we have a perfect square, then we can apply this formula. Alright, so if I have x squared minus 9, alright, I want to look for two important things. The first thing is that I have a minus there. Alright, since subtraction is occurring between these, alright, I'm good. And then x squared is really x times x. 9 is really 3 times 3. Alright, so this is a difference of two squares. Okay. So when I have that, I write x plus 3 and x minus 3. Okay, so I rewrite one of my factors, I rewrite the other one. One gets a plus, one gets a minus. Alright, important thing here, be careful if it has a plus there. Okay, this does not work. Alright, okay, let's look at some examples. So let's go to the second page. Alright, so I want to look at these. Alright, it says factor completely x squared plus negative 4. Alright, so the two things that I want to look for is I want to, 1, alright, is each term. Okay, remember these are terms. This is a term. A perfect square. Okay, and 2, is it subtraction? Alright, so first let's see, alright, is this a perfect square? Alright, is that an even exponent? Yes, right? This is x times x. Alright, what times itself gives me 4? Alright, or what is the square root of 4? Alright, that's 2 times 2. Okay, so I'm going to write this. I take one of these and one of these, x and 2. Alright, 1 always gets a plus, 1 always gets a minus. Okay, that's it, just our shortcut. Alright, so that's my answer. All right. If you guys remember from the other day, if I took x squared, all right, the other day we wrote it like this, plus 0x to fill in that linear term, and then we factored it, we got the same answer. All right, it works the same way. All right, but this is just a shortcut if I notice that those are perfect squares. If I did it this way, and then I did my t, it would work out the same way. All right, so let's look at 2. So y squared and 49, all right, are those perfect squares? What times itself would give me y squared? Y times y. All right, what times itself would give me 49? Okay, 7 times 7. Okay, so I'm going to take a y and a 7, a y and a 7. One gets a plus, one gets a minus, and it doesn't matter which way that I do it. Okay. Oh yeah, one other thing. I always want to check and see if I can take out a GCF first, which I haven't been doing yet, and that's my bad. I should have done that first. All right, my GCF here would have just been 1, no GCF, right? And same thing here. All right, that's why I didn't do it, because I didn't see that there wasn't a GCF. All right, let's look at 3. All right, so the first thing I want to do is each term is a perfect square. X times x, that works. 3 times 3. All right, then I want to check if it's subtraction. No, it's not. It's addition. All right, so if it's addition, this cannot be factored. There's nothing I can do with that. It cannot be factored. Or we can call that prime. Okay. All right. How about 4? Okay, so 4, are these perfect squares? Yes, x and x. How about 1? 1's kind of a tricky one, but 1 times 1, right, is -1. So I have x, I have 1, x, I have 1. 1 gets a plus, 1 gets a minus. Okay. All right, 2x squared and -4. So this is where I first need to see, do I have a GCF? Do I have a GCF between 2 and 8? Yes, it's 2. All right, so I want to take out a 2 here. All right, so now I have 2. These cancel. I have x squared minus 4. Okay. Now, is this a perfect square or a difference of squares? Yes, I have x and x. I have 2 and 2. So I have x, 4. X, 4. 1 gets a plus, 1 gets a minus. Remember, it doesn't matter which order. Okay, and what else do I need to remember? I need to remember that that 2 comes down. My final answer is this whole thing. All right, why don't you guys go ahead and try 6. All right, so go ahead and pause this. Give 6 a try. All right, I'm going to go ahead and do it. My GCF, okay, is 3. So I'm going to factor out a 3. Okay, so I have 3x squared minus 1. All right, now I'm going to see, are these both perfect squares? Because I see my minus is there, so this is definitely subtraction. X times x, 1 times 1. So the 3 stays on the outside. X plus 1, x minus 1. Okay. Okay, you guys can try 7 as well. Okay, they just should be x plus 11, a minus 11. All right, and we're going to do 8 together. Okay, so 8. Hopefully some of you guys, maybe you've already paused it and you are just checking your work here. That's fine too. All right, I want to see, all right, I have x to the 4th minus 4y squared. So are these perfect squares? All right, remember, it doesn't just have to be 2 from my front page here. All right, it said as long as each any exponent on the variable is even. Alright, so is this an even variable? Yeah. So x squared times x squared would give me x to the fourth. Alright, and what would give me 4y squared? How about 2y times 2y? 4y squared? Yep, that works. Alright, so I'm going to write one of these first ones, one of the second ones, one of the first, one of the second, one gets a plus, one gets a minus. Alright, and how about 9? Okay, 9 is going to be, okay, are these perfect squares? Y squared, yes, that's y times y. 36, what is 36 a perfect square of? If I'm not sure, I can always take out my calculator and do the square root of 36, which equals 6. So I know that 6z times 6z is my answer. So then I'm going to do y and 6z, y and 6z. One gets a plus, one gets a minus. Alright, so remember, all of these can be done with the shortcut as long as I know that each term is a perfect square and then I know that it is subtraction. Alright, if it's addition, it does not work. If these are not perfect squares, this does not work. Alright, if you don't notice that it's a perfect square and you do it the long way, that's fine. You're still going to get the same answer. Alright, this is just a little shortcut if you guys happen to notice it. Alright, you guys have a good day. See you tomorrow. I should be back.